Hello students, today we are going to discuss third topic from vector calculus, which is the vector identities. Now here we will discuss the properties of operator del. If u and v are the vector functions and phi and psi are the scalar function, that is u is a vector, v is a vector and phi and psi are scalar, then the first identity is divergence of phi into vector u, divergence of del dot phi into u. Here phi is a scalar function and u is a vector, so divergence of phi into u, vector u, is equal to phi into divergence of u bar plus del phi dot u bar, that is the gradient of phi dot u bar, which is your first identity. Divergence of phi into u bar is equal to phi into divergence of u bar plus gradient of phi dot product with vector u. Second identity similar, just replace dot by cross. So second identity is del cross phi into vector u, that is curl of phi into vector u, is equal to, you can take phi outside, phi into curl of u bar plus gradient of phi cross vector u. These two identities are important. While solving the example, definitely these two identities useful. The third identity is divergence of u bar cross v bar is equal to v bar dot del cross u bar minus u bar dot del cross v bar. And fourth identity is gradient of phi into psi. Gradient of phi into psi. I am here, there is no simple product, so we can read this as gradient of phi into psi. Here dot is there, so divergence of phi into u bar. So gradient of phi into psi is equal to, take phi outside, phi into gradient of psi plus grad phi into psi. Some important result or important properties of del. So del square is equal to del dot del. Del square equal to del, and we know that del is what? I into del by del x plus j into del by del y plus k into del by del z. So del dot del is what? Is simply del square by del x square plus del square by del y square plus del square by del z square. So you must remember this, del square equal to del dot del. Second, del dot r bar is equal to 3. R bar is equal to what? Xi bar plus yj bar plus zk bar. Xi plus yj plus zk. And if we differentiate this, then we get, that is derivative of x with respect to x is 1, with respect to y is 1, with respect to z is equal to 1. So derivative of this xy f1 f2 f3 with respect to xy z is equal to 1. Therefore divergence of r bar equal to 3. Then curl of r bar equal to 0. You know very well how to find curl of r bar. Curl of r bar means what? It is a just determinant. First row is I, j, k, second row is what? Differentiation with respect to x, y, z, and third row is f1, f2, f3. And third row of determinant is what? R bar is what? xi plus yj plus zk. So x, y, and z. And if you find the value of that determinant, you will get 0. So curl of r bar equal to 0. Divergence of a bar equal to 0. A bar is a constant vector. A bar is constant vector like I plus j plus k. So derivative of constant is equal to 0. Therefore del dot a bar equal to 0. A bar is constant vector. Therefore curl of a bar is also equal to 0. A bar dot del r bar equal to a bar. Gradient of a bar dot r bar equal to a bar, and r bar dot r bar equal to r square. R bar dot r bar is equal to